You've been using Python for a while now. You know how to write the functions, you know how to use lists, you know how to build classes. But let me ask you something. Do you actually know how Python works? Not how to use it, how it actually works under the hood. For example, why does this work? Or this? Or maybe this? If your answer is because Python is built that way, you are right, but you are not deep enough. Watch this. I'm going to write a class with just two methods. The name of this class is French deck and have two methods, okay? That's it. And from these two methods, I'm going to get all of this for free. Indexing, slicing, random access, iteration, and membership testing. All from two methods. That's not magic, that's a Python data model. And by the end of this episode, you will understand exactly how it works, and you will never look at Python the same way again. Let's start with one idea. Python has a contract with every object inside it. The contract says, implement certain methods, and I'll treat you like a native part of this language. That's it. That's the whole idea. Now, what are these methods? Len, getItem, reaper, add, and bool. They all have something in common. Double underscore, name, double underscore. We call them dunder methods, short for double underscore. You might also hear special methods or magic methods, same thing. Here's the important part. Every piece of syntax you write in Python is secretly calling one of this. Every single one, there is no magic every time Python does something. It's calling a method with a specific name, a name you can implement yourself. That table on screen, that's the Python data model, not a library, not a framework, the API of the language itself, okay? And here's what this means for you. For example, if you write a class and you implement the right methods, Python will treat your class exactly like a built-in type, okay? Your class will support len, your class will support indexing, your class will work in a for loop, not because Python is doing you a favor, because you signed the contract, okay? Let's go one level deeper. When you write len my list, what actually happens inside Python? Layer 1, your code. You call len simple. Layer 2, CPython, the engine running your Python code, takes over. It finds len, it sees its building function, it calls something internally called PyObjectSize, okay? Layer 3, for a list specifically. Python doesn't count anything. A list in memory looks like this. OB size is always there, always updated. When you append to a list, OB size goes up by 1. When you pop, it goes down by 1, okay? So when you call len my list, Python just reads this number. No counting, no looping. So big O1 always. Now for your own classes, when you define len, Python calls it the same way, okay? Just one level up, same contract and same idea. Okay, now we know what the data model is. Now let's actually use it and build something real. A French deck, a S1.52 card playing deck. We are going to build it from scratch, step by step, and we are going to see exactly what the data model gives us. First, the card. Name tuple is a tool from Python's standard library. It creates a simple class with name fields. Here, a card has two fields, rank, the number or letter, and suit, the symbol. We create a card, ace of spades. C.rank gives us the rank, and C.suit gives us the suit. But why name tuple? Why not a regular class? Regular class is something, for example, like this. What do you think this prints? False. Two ace of spades not equal. Because by default, Python compares memory addresses, not values. These two cards live in different places in memory, so Python says they are different. That's wrong. Two ace of spades should be equal. Now with name tuple. The print is true because name tuple compares by value, not by memory addresses. And it prints cleanly too. Name tuple inherits EQ and reaper from tuple. We get both for free, no extra cost. A card is what we call a value object. Its identity comes from its values, not from where it lives in memory. Name tuple is the right tool for value objects. Now the deck. Rank is a list of all possible ranks. Range 2, 11 gives us 2 through 10. We convert each number to a string, then we add the face cards. So rank is this, okay? 30 ranks total. Suits is just string that we split into a list. 4 suits. Notice something. Ranks and suits are defined directly on the class, not inside in it. These are class attributes. They belong to the class itself, not to each individual deck. Every deck shares the same ranks and suits. One copy in memory no matter how many decks you create. Here we built all 52 cards. This is a list comprehension with 2 loops. The outer loop goes throughout each suit. The inner loop goes throughout each rank. So for spades, we get 2, 3, 4 all the way to ace. Then diamonds, then clubs, then hearts. So we have 4 cross 30 equals to 52 cards. Cards is an instance attribute. Each deck has its own list of cards. The underscore in cards is a convention. It means this is a private. Don't access it directly from outside the class. Now let's add our first under method. Len returns the number of cards. We just delegate to len self.underscore cards. The list already knows its own len 01. So our len is 012. We create a deck, we call len. It works. Now the second under method, getItem. GetItem takes a position and returns the card at that position. We delegate to self.underscore cards position. The list handles the rest. Now watch what this one method gives us. Deck 0. The first card. Python calls deck.getItem_0. Deck 0 to 3. The first 3 cards. Slicing works. We didn't write any slicing code. Python passes the slice object to _getItem_. And the list handles it. A for loop. We didn't write either under method. So how does this work? When Python sees a for loop, it first looks for either under method. We don't have it. So Python falls back to getItem method. It calls deck 0, then deck 1, then deck 2, and keeps going until it gets an index error. Then it stops. That's the fallback automatic free. The in operator. We didn't write contains method. So Python iterates throughout every card and checks for a match. It works, but it's all in. We'll come back to this in a later episode when we cover hash tables. Let's look at what we have. 2 methods. 6 capabilities. 2 methods, that's the contract. Now, let's talk about the dunder method you'll use in almost every class you write. First, reaper dunder method. We have a vector, let's print it. A memory address, useless. Let's fix it. Reaper dunder method returns a string that represents the object. The output should look like valid Python that recreates it. There's also str dunder method for cleaner user-facing format. But if you only write write reaper dunder method, it works everywhere. Next episode, arrays and dynamic arrays. How Python's list actually works in memory. Why append is sometimes slow, and how to build a dynamic array from scratch. Thank you for watching and see you later.